All right, we are continuing with example 3 on unit 11, day 2. We're still doing volume of prisms and cylinders. So now we're looking at example 3. Marta's repurposing a sandbox as a garden and is buying soil from her school's fundraiser. Estimate the number of bags she would need. So we need to figure out the volume of the sandbox and the volume of the bag in order to figure out how many bags we can fit in this. One thing that I noticed about the picture is the dimensions of the sandbox are in feet, but the dimensions of the bags are in inches. So I think the first thing we're going to do is take this 4 feet and convert it to inches. There are 12 inches in a foot, so if you do 4 feet times 12, that will give us 48 inches. So we want the volume of the sandbox. We have a square sandbox. So our volume is going to equal, the base would be, instead of 4 feet by 4 feet, we're going to say 48 by 48. And then the height of the sandbox is 10. Let me double check my math. Looks like that is 23,040. That would be in inches cubed. The volume of the bag looks like we can do this in any order, but 10 by 18 and then times 5 could be considered the 3 numbers I see for the bag's measurements. If you multiply those together, we get 900 inches cubed. So each bag can fill 900 of the 23,000. So how we can figure out how many bags, we take the total volume we need, and you're going to divide it by, each bag covers 900 inches cubed, and it comes out to 25.6 bags. But realistically, you can't go to the store and be like, I want part of a bag. So we're going to say we need 26 bags. Oops. All together, because you can't buy part of a bag. All right, same idea, only this one we're going to be talking about a cylinder. This one says, Catherine is using cans of juice to fill a cylindrical pitcher. So we have a cylinder now instead of a prism. Your cylinder is 11 inches tall and it has a radius of 4. So our big cylinder is 11 inches, which isn't really very big, and a radius of 4. We're going to fill that up with juice from cans that are only these are only 6 inches tall with a radius of 2. All right, how many cans will it take? So we're filling something up. We want to use the volume formula. The big one would be 4 squared times 11. So this is the volume of the big pitcher. That comes out to 552.9 inches cubed. So that's our pitcher. Then the volume of the can, pi times 2 squared times 6. That's 75.4. Those are how much is in a can, and we need to know how many cans will it take to fill up the pitcher. So just like the last one, we're going to divide the 2 answers to see how many cans that would take. So 552.9 divided by 75.4 in each can comes out to about 7.3, but again, we're not gonna, they round it to, let's see, about 8 cans, I guess. 8 cans would overflow it then. So we might have to go 7 there. I might double check that one. All right, this one, sometimes they get into comparing shapes. This one is a regular prism on the left, and this is an oblique prism on the right. They just want you to compare that the volume on the one on the left, A times B times C, is going to be equal to the volume of the one on the right, because wherever the 90-degree corner is, whether it's pushed sideways or it's straight up, is still the same. So these have the same base and height. So the volumes are equal. So anything that has the same base and height, the volumes will be equal, even if it's pushed sideways like that. Okay, this one compares again, but this one gives us numbers in it. It says prism A has a volume of 192. Volume B is half the volume of A. So let's take 192 and divide it by 2. We want to figure out what half of that is. Half of 192 is 96. Okay, what is the value of A? They're wanting us then to use that information to find, the question says, what is the value of A? We know to find volume, we would do length times width times height for this kind. So our volume is 96 equals, our length times width is 4 times 6, and then we have the height over here is just A. I don't know what that is. So when I say 4 times 6, we just need to multiply. 4 times 6 is 24, and we have the A. So the opposite of multiplying is to divide the 24 to the other side. So to get A by itself, we have to divide 24 to the other side. And 96 divided by 24 is 4. So it's important to read these word problems. It's not always obvious just in the picture what you're supposed to do. And sometimes they don't have pictures at all. Like for instance, this one says, a stack of 1 dozen cookies with a diameter of 3.5 fits in a cylindrical container. Remember, a cylindrical container is a cylinder. The volume of a cylinder formula was pi r squared h. They gave us the volume, so we're going to put that number in, and they gave us the diameter. The volume number would go here, where it's V equals and then it says the diameter is 3.5. Well, the radius is half of that much. So if you take 3.5 and you divide by 2, the radius would be 1.75. So there's a lot of numbers in this equation that we can fill in. A couple different ways you could do this. We could go ahead and multiply these numbers together first. You have a pi button, and if you can't find a pi button on your calculator, you can just use 3.14 is fine for now. So on the left, I have 86.59 was the volume, equals, if I multiply that together, I get about 9.62, and then I still have my h. So that was just multiplying the pi r squared together. So to get h by itself, when you have multiplication, the opposite is to divide by the number in front. So if you take 86.59 and we divide by 9.62, we get about 9. The height of the cylinder is 9 inches. So if I was to draw this over here, it's not a very good cylinder. We have a 9-inch cylinder, with a diameter of 1.75 to hold our dozen cookies. You guys know how many cookies are in a dozen? A dozen cookies is 12 cookies. We can fit 12 cookies in 9 inches. It says, what is the thickness of each cookie? So it didn't stop at just asking us what's the height of the cylinder. It wants to know what is the thickness of each cookie. So we would take our 9 inches and divide it by 12 cookies. Each cookie is 0.75 or 3/4 of an inch tall. So that is how tall each cookie would be.